Hello everyone. This is a lecture 2 for machine learning techniques, and today we're going to look into machine learning basics. So what is a computer program or a computer model or a machine learning program? So it is something that learns from experience with respect to tasks and performance measure. So performance measure at said tasks should increase with experience. Now, in the last lecture, we saw different types of learning. Now we should look into how to create a model that learns. And in particular, we will learn about if a model is good, how to make a model good, and the theory behind why a model is good. What is a generalization of a model? A model is said to be good only if it makes accurate predictions or has lesser errors. This is called generalization. In this entire lecture, we are going to take the example of a student studying for his exams and draw parallels to machine learning. So here, the training data is your textbook and homework problems. The test data is obviously your final exams, and your goal is not to memorize but to learn concepts so that you can answer any question in the exam. And your machine learning model needs to do the same. What is underfitting? It means that the model is too simple or hasn't been trained on enough data, so it doesn't capture patterns well, it ignores important information. Or for a student studying for a very short amount of time for his exams, he is bound to fail. So in underfitting, the model or student would perform badly on both the training data, which is the homework, and also the test data, which is the final exam. What is overfitting? It is the opposite of underfitting. The model learns the training data perfectly. In fact, so perfectly that it also learns the random noise and the outliers. It essentially memorizes all of the data. Or for a student, he memorizes every single homework problem, including the errors in the questions. But when asked even a small different question, he doesn't have the answer. It's like learning 1 plus 1 equals to 2 and 1 plus 3 equals to 4 again and again. But he cannot answer what is 2 plus 2 because he has not seen that data before. So, the model performs extremely well on training data but does very poorly on test data. Now, our task is to find a balance, a model that is just right. A model that is called a Goldilocks model. This is a story that we all would have heard when we were young, where the girl Goldilocks prefers porridge that is not hot nor cold, but just the right temperature, which is also why life on Earth exists. It's at an optimum temperature compared to Venus and Mars. So the concept is that the model must capture the patterns properly and not the noise or the outliers. It should not underfit nor overfit. It's like studying for an exam by understanding the concepts and principles from homework so you can solve any new problems from learned topics in your exams. Here, the model performs well on both training data and test data. This is the graph that is commonly shown to depict the underfitting, overfitting, and the best fit for the model. With more training, the training error will always continue to reduce, but the test error will reduce up to a point and then start to increase again. So this point where it is at the least is called your best fit for your models. Now this is a graph to compare across all three: underfitting, a good fit, and overfitting. In underfitting, you can see the patterns are not learned properly. In a good fit, the patterns are learned quite well, maybe probably except a few outliers. Whereas in overfitting, it fits exactly, which is not what we want, because when we look at new data, it does not fit well at all. So now, how do we find the best fit? Or how do we solve this Goldilocks problem? How do we control our model? This is done via hyperparameters. Hyperparameters are what we set to the model before learning to make it learn in a certain way. For a student, the analogy is like studying. How many hours will you study? And how many problems will you study? Or how much theory will you read? So all these affect how much you learn. So the difference between parameters and hyperparameters is that parameters control the model, These parameters are learned by the machine looking at data and learning from them, whereas the parameters that control these parameters are called hyperparameters, which are set by us before training the models. Now, how do we find the best hyperparameters, or rather, how do we tune the parameters, the hyperparameters? The training set cannot be used since it will overfit beyond a point. We also cannot use a test set, otherwise the model will start to learn from the test set and will beat the purpose of having a test set. This is why we come up with the validation set. This is like the mock exams you take to test your knowledge on a particular subject before the actual exam, which will be your test set. So, any data is split into train set, validation set, and test set. Usually, training set is set to 60 to 80%, validation 10 to 20, and test set 10 to 20%. So, several models are initially learned based off the patterns in the training set based off your own hyperparameter settings. Then we test it on the validation set, and if we're happy with the results, we move on to the test set. Else, we change the hyperparameters again by looking at the validation set, train again, validate it again, and if we are satisfied, then only we test it on the test set. Now, moving on to the theory. Why does everything work the way it does? Everything is part of the bias variance trade-off. The errors of a model can be broken down into two main parts, either bias or variance. Underfitting is a problem of bias, overfitting is a problem of high variance. We shall look at this analogy based off archery. What is bias? It is basically error from the wrong assumptions. Or rather, the model learns the wrong things, but it learns the wrong things consistently. If we look at this archery analogy, we can see that the archer is off the target, but every time he's very close. So in short, high bias is underfitting. What is variance? It is basically error from too much complexity. Rather, the model fluctuates a lot and is unstable. If you look at the archery analogy, the aim is at the center, but it is not consistent. It is very wide and spread apart. So in short, higher variance is overfitting. What is the bias variance trade-off? The fundamental challenge of machine learning is to minimize both bias and variance. But the issue is both are inversely proportional to each other. It is a trade-off between the both. When you decrease bias, variance increases. But at the same time, when you decrease variance, the bias is very high. So our goal is to find the sweet spot in the model complexity that minimizes the total error. And that will be your best fit. To summarize what we have learned in this lecture, we learned about the Goldilocks problem, wherein we look at underfitting, where a model performs poorly on both training and test data because of high bias. Overfitting, where the model is great on training data but very bad on test data because of high variance. And how do we find the best fit? This is done via hyperparameter tuning, and we learn the theory behind how all of this work via a bias variance trade-off to build a model that generalizes well. Thank you, and see you all in the next lecture.